In this module, I'll give you a demonstration of the as-planned versus as-built analysis. This method involves a comparison of the as-planned and as-built programs. This method is widely used in EOT claims and is based on an analysis of the variance in duration between the two programs. This variance is suitably backed up with a cause and effect analysis which details the delay and disruptive events and the resultant impact of the same to the program. Strengths. First, this analysis is suitable for simple programs and easy to understand. Second, it is usually used when there is a concern over the validity of the baseline and/or updated programs. Third, complex software-based modeling is not required, therefore a common sense approach is applied. This method finds favor with a lot of professionals who prefer to use a very simplistic or a big picture strategy to resolve delay issues. Weaknesses. This analysis requires professionals to use practical planning or project management experience and knowledge in order to establish the project's critical path based on a detailed review of the contract documents. However, different experts may reach different conclusions, and this could result in a lot of debates. Now I'll give you a practical demonstration of this technique in MS Project. Please open the Excel spreadsheet provided in the resource folder, and the first thing to do is to set up our as-planned program. Open your project information and make sure that your start date is in line with the data provided in the Excel spreadsheet. This is what I'm doing at the moment. So the start and current dates are equal to the 18th of May 2015. And once we insert all the activities from the as-planned program, we will add the duration, we will link it, we'll create a baseline, and once that's done, we will create the as-built program and then compare it with the baseline. After this is done, I'll insert a new column and call it Notes. So in this Notes column, I'll specify the reasons for the variance between the as-planned and as-built data, such as start, finish dates, and durations. So here I'm just creating the as-planned program. The durations have been updated. I've linked all the activities, and the next step is to remove all the constraints that have been automatically implemented by MS Project. Please switch all the constraint types to the default as soon as possible. Everything looks good. There's no change to the finish date. So now it's time to set the baseline. So go to Set Baseline and set your first baseline. Okay, so let's have a look at the baseline in the tracking Gantt view. And there it is. The dark gray bars represent the baseline. Before we update the activities to as-built dates, I'm going to insert columns for actual start, actual finish, and actual duration. This is required to get a clear perspective of the as-built program. Once these columns have been inserted, the next step is to copy all the as-built data from Excel and paste it here onto our program in MS Project. Now it's time to insert our Notes column for entering information about reasons for delays and/or disruption. If you remember, this delay analysis methodology does not require any modeling. It's purely a logical, high-level, objective assessment based on experience. So the as-built dates have been updated. So let's go to the tracking Gantt view, and we can see the differences between the as-planned and the as-built Gantt bars. So now we will insert reasons for these variances. In order to make things a bit more clearer, I'm going to insert a finish variance column. Now before I start entering notes, I'm just going to save this program layout as a new table under a new name. Now the information to be entered into the notes column should be derived from your contemporary records. For this exercise, you can get the requisite data from the Excel spreadsheet. And there you have it. This is your basic as-planned versus as-built analysis. Please do remember that every statement you enter here should be backed up by contemporary records and evidence. Please remember to populate the Excel delay analysis table completely. All the relevant sections have to be filled in, such as the as-planned start-finish, as-built start-finish, the variance between the as-planned and as-built data. Based on this information, you have to make an overall assessment of delay and allocate liability accordingly. In other words, was it a contractor delay, employer delay, or a concurrent delay? Also do remember that this delay analysis table contains different sections for critical delays and non-critical delays. Critical delays result in an overall delay to the project completion date, whereas non-critical delays do not. However, you could have disruption claims arising from non-critical delays. So it is extremely important to record non-critical delays as well. Once you've populated this delay analysis table, you've completed your as-planned versus as-built analysis.